Weekend Bharti with your mentor Avilash Sarkar. To start this episode, I first apologize to all my viewers as because yesterday I couldn't post a informative video that I usually don't do because but that has done just to be in contact with my viewers and the love and the respect that I am getting from my viewers to on that to respect that in turn I have put a continuity, you can say it's not at all a video, it's a connection that you can say that it's just for the sake of the respect I have to my viewers. Like basically I'm a service person. I'm working in a private sector, and there often may happen that I could not manage time to make videos and post it in time, and that has happened yesterday also. I've been involved in some emergencies in plant, and as because I'm in a responsible position in my organizations, so I cannot avoid, or you can say that my principal responsibility is my job first, and what I am doing here in this through this YouTube channel just to satisfy my own passion. But nevertheless, it is on turn. It's not. I can value it equally because some of the aspirants who were preparing for higher competitive examination have some faith on my videos that has been reflected in my earlier episodes through their comments. So I respect this. You can say now it is not only a passion, it is also a responsibility for me. So sorry for that. On that note, I apologize again to all my viewers. So I will try not to discontinue such incidents will happen again. I will try to keep my promise, and on that I will continue this episode that I have started on binomial. So what we have learned till now on the binomial theory, that any expansion of binomial series is being maintained with three criteria, that is the two term in binomial, their power is in reverse order of changing, starting from maximum order of the binomial, maximum order of the binomial minimum to minimum 0. This is one. Second one is coefficient follows Pascal's triangle. So this we have found, but while I doing and try to approach a higher order of binomial series, their Pascal's triangle itself is have some limitation of calculating the higher series coefficient, because that will follow the same pattern, and every time I have to do it from the start point where any series starts 1. From there we have to expand it and have to reach where the respective power coefficient will be available. So that means we will follow the equilateral triangle and continuously try to calculate till we reach the required power series and their coefficient. So this is a limitation. So in case of higher order, it definitely not a process to follow, because because people may lose their cool or image their concentration too. So there must be something, as I told. So on that basis, I have started a concept of factorial. So what I explain, factorial is nothing but factorial of any natural number n is the product of all the natural numbers starting from that number till 1. So if I say the factorial n is equal to n minus 1, n minus 2, so all natural number till 1, I will get factorial n. This is the definition. Now, in this factorial, the next that I will explain characteristics. There are several characteristics, but out of this, the one characteristic that will help me while I will come back to the binomial series and express in terms of factorial. So, what is that property? Property is that if I start from n and if I leave the next as factorial, this also will same as factorial n. Or else if I keep it this up to this term and the next term I will make the factorial, this also will be the same. So that means for any number, natural number, while we are doing factorial, I can end up anywhere and the last number of that would be termed as a factorial, and the remaining above it will come as a product of that, and that has to be equivalent to the main factorial. Okay, so this I have example. So if I take a real example, let's say 6 is nothing but 6, 5, 4, 3, 2, 1. So I can end up anywhere in between. Let's say 6 into factorial 5 I can write, or I can write 6 into 5 into factorial 4, or I can write 6 into 5 into 4 into factorial. See, that is on basis of my need, but it can be done. So wherever I am stopping, the last number should be represented as a factorial and remaining will come as a product, and that is equivalent to the main factorial of the number. Okay, so this is one rule that is useful. Now we'll come back to the series where we have expressed or expanded a series of x plus y whole 5 that we have taken as x to the power 5, because that will start from the maximum power plus 5 x to the power 4y plus 10 x to the power x cube y square plus 10 x square y cube plus 5 x y to the power 4, and the input is 5. So where if we see the power of the first term starting from 5, reducing by 1 in each term and moving to the last term up to 0. So now if I try to represent this term in another way in terms of factorial, so I am writing is factorial 5 minus 0, or let's say factorial 5 again. Why I am writing, I will explain it. Factorial 0, and if you see, this is x to the power 5 y to the power 0. So that means what I am doing, I am keeping the maximum power. I am representing this is the maximum power 5 as a factorial of this on the numerator. In the denominator, what I am writing, factorial of the power of the first term, factorial of the power of the second term. Similarly, the next term I am keeping the same factorial for the highest power, and I am writing 4 factorial, because the power of first term is 4 and the second term is 1, and I am keeping the term x to the power 4 y. Now see whether I am getting by calculating this the coefficient 5 or not. Now factorial 5, as I said, factorial 5 into factorial 4 we can write, and below is factorial 4 into factorial 1. Now 4 can be cancelled out. This is 5. Factorial 1 means what I said earlier, factorial 1 is 1. So ultimately I am getting 5. So this is clarified. So I can write this in this term just to correlate or establish some generic representation of the coefficient, whether we can use this factorial. So we'll see. Now in the next term, if I follow the same rule that I have explained, that is the factorial of the highest power below the factorial of the power of first item, factorial of the power of second item, and this is x cube y square. Now let's see this represent 10 or not. So factorial 5 means 5 into 4 into factorial 3, that I can write, and below you are having factorial 3 and 2 you can express in 2 into 1 factorial. So this can be cancelled out. 2 will cancel out with 2, it will give you 10. So there is 10, it's matching. Okay, fine. Moving to the next term, that is there again it takes 10. So with the same concept, factorial 5 will come in the numerator. Factorial of the first term is square, so 2. Second term is 3. Okay, so now this is x square y cube. Okay, now see this and this having no alteration. Only thing is that we have altered the position of factorial 2 or factorial 3, but if I calculate, I will get definitely the same result that I have got for this case, because there is no change in that. So I will get definitely 10. So this is 10 is matching. The next is, if I follow the same rule, factorial 5, factorial the power of first is 1, power of second term is 4. Now see this and this also is matching. Only thing is being reversed. So if this is having a result of 5, this also definitely be 5. So I need not to show you the calculation x y to the power 4. And the last term, factorial 5, the similar way, what is the coefficient of the power of first term? 0. So factorial 0 and factorial 5 again. The power of this, it is y to the power 5. Now factorial 0, as I said, the logically can be proved is equal to 1, that I have shown in the last video. So factorial 0, if it is put 1, factorial 5 will cancel, ultimately this is equal to 1. So this is also is equal to 1. Okay, one more thing you can see, that from the both end the coefficient, now this could be, you can say the coefficient of the term, first term, the coefficients are same. If you move the next term from the both end, from the left hand side this is second, from the right hand side this is second, this coefficient is same. From the left hand side if it is third, this is third. From the right hand side this coefficient is same. That means the equidistant coefficient for that binomial series from either end is equal to 1. So what we can say, the coefficient of the binomial expanded terms from both end have same value. So this we can write by seeing the thing. Okay, so this is the first conclusion that we can make. Now this have following the same pattern. Now let me understand whether other one or two series following the same rule or not. So as you know, x to the power x plus y equal to the 4, this is x to the power 4 plus 3 x square x cube y plus 6 x square y square plus 3 x y cube, and then plus 6 and 3, and then this is y to the power 4. isn't it? So this was the series. Okay, if I remember correctly, 1 1 1 1 2 1 1 3 3 1. This is the third. This 1 4 6. Sorry, this would be the 4. This is 4, not 3. Okay. Excuse me. So now this is express x plus 4 whole to the 4 as this one. Now let us understand whether this rule is being can be implemented in this expansion or not. So if I say factorial 4, the highest power of 4, the power of the first term is 4, power of the second term must definitely be 0 because this is y to the power 0 you can take. Second term factorial 4, then first factorial 3 factorial 1 q y, then factorial 4 factorial 2 factorial 2 x square y square plus factorial 4 factorial 1 factorial 3 x y cube, and then next factorial 4 factorial 0 factorial 4 y to the 4. Now see, 4 means 4 into factorial 3 factorial 3 will be cancelled out, factorial 1 is equal to 1, so it will remain as 4. There factorial 4 can be written one of the 4 into 3. Now 2 is equal to 2 into 1 means 2, 2 into 1 into that 4 will come, and this is 4 into factorial 3, so 12 by 2. What I am saying, factorial 4 can be written as 4 into 3 into factorial 2, and below is factorial 2, and one of the factorial I can expand. So this factorial cancelled, 2 2 the 4, so 2 into 3 6. So you can see that is matching the coefficient. Now the rest, as I said, this the extreme the equal distant points are of equal value. So this is 2 from the left hand side, this is second from the left hand side, so this must be same. If it is 4, this must be 4, and the remaining, this is 1, this is 1, can be clarified. So you can see any expansion binomial expression or series can be expressed in terms of this kind of factorial with this concept, where this numerator will follow the factorial of highest power, and below is the factorial of first term into factorial of second term. So this can be the rule for any coefficient. Okay, so in each coefficient can be written as factorial of the highest power in the numerator. So in the numerator will follow the factorial of the highest power, and below the factorial denominator factorial of the first term into the factorial of the second term. Okay, so this rule as understood. Now this representation, any representation of this kind can also be represented with a unique formula or unique representation that is called the binomial coefficient. Actually, this when I will represent in this form or a generic form, that is NCR. Now this how the value will be said here. If I say NCR is the generic form which is said to be the binomial coefficient. Now this is called binomial coefficient, and where n is the highest power of the series, and r is the term of the expansion. That means if I say this is term of the expansion series, this will start from t0, not t1. This is 0th term of the binomial expression, and r accordingly will be said to be r is equal to 0. So the first term is we represent as t0, 0th term, this is first term. So r will represent the r means rth term, okay, and r is starting from 0. R starts from 0. So 0th term, the r value is 0. So if I want to represent in this form of the binomial coefficient, how we can represent this? The first one that I have given as an example, this series, this we can say 5c0. This is 0th term. This is 5 is the maximum power. 5c0 x 5. And the next one is 5c1. This is 1th term. 5c1 x to the power 4 y second. 5c2 x to the power x cube y square. 5c3 x square y cube. 5c4 x y to the power 4 and 5c5 y to the. So this is represented as this way. So further, this also can be represented just only in terms of c0 x5 c1 instead of writing 5 every time, because we know this will definitely carry the maximum power of the binomial series that is there already. So this, if you write or not, it will represent carrying the maximum or highest power of the binomial series. You need not to write it. So this is x to the power 4 y plus c2 x cube y square plus c3 x square y cube plus c4 x y to the power 4 plus c5 y to the power 5. So student may think, so if we write this like this, there may be confusion that whether c1 for any kind of expression has the same value. No, it depends on the unwritten or the hidden terms that is there, and that depends on the highest power of the series that we are talking about or what we are expressing. So this, don't forget, even if you are not writing this c0 for x plus y whole to the power 5 is not same as x plus y whole to the power 4, because this is carrying the maximum power of the series. Understood? So up to this, I think you have understood. Now with this concept, now this is called a series that we are establishing with a kind of correlation or similarity. Now what I mean to say, if I express x plus 5, so what we are writing, c0 x5 c1 x to the power 4y plus c2 x cube y square plus c3 x square y cube plus c4 x y to the power 4 and c5 y to the power 5. Sorry. Now what we can write for x to the power x plus y over to the 4, we are writing c0 x to the power 4 plus c1 x to the power x cube y plus c2 x square y square plus c3 x y cube plus c4 y to the power 4. Okay, so now we can see the similarity, both we have explained. Now with this similarity, can we write a series of x to the power whole n where n will represent a generic series where n could be any integer. N could be any integer, natural number, real number, and non-zero. This is the criteria where n could be anything which is equal to an integer, natural number, real number, and non-zero. So this can be represented in terms of, first I will write in terms of the generic form of this nc0 x to the power n plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square and plus dot 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 till n will match this number will match the highest power, that is ncn, as it is happening here. It is matching the highest power, because we can assume this carrying the highest power of on the top of this, and at bottom this is 4. So this coefficient will go till it is matching the highest power of the coefficient, and x will be 0 here, and the second term will carry the maximum power. So before the terms, what would be the case? nc n minus 1 x y to the power n minus 1. So you can correlate with this and the power of the second term. So with that we can correlate the thing how it is moving. 0 means y0, the second term is 0. 1 means second term is 1, 2. So this way also you can remember. And the remaining thing, usually that the rule that I have said, the first term power will reduce by 1 in every term starting from the highest power, and on the reverse order y will increase from 0 to the maximum power of the order binomial series. Okay, so now we can understand how we have faced the generic formula of any binomial expression power n, where n could be any value. You can take any value, let's say n is equal to 32, as we are talking about how will express this when n value is very high. We cannot make it with the help of your Pascal's triangle. So this is the formula, very generic. You can go up to any finite series, whether it is 1000, 2000, 5000, 1 lakh. If you have the patience, you can express it in this form. Okay, so I will end up here. In the next video I will start correlating. First I will explain some of the properties of the factorial that I have left out, because one of such properties that I have explained that is needed if from this, if I turn back to the factorial, how it is now. The series in a generic form, this is the formula nc1. Now if I want to express in term of factorial, so how will you express? That will be factorial n on the top, factorial n minus 1 at the bottom, and the remaining is factorial n. So this will follow the same rule from where we have reached here. So this is just the reverse method of expressing this in terms of factorial. So now how will you solve it? Because factorial n can be written as n, and the next term can be put it into factorial, as because we are matching this. So this is matching factorial n and this is 1, so this can be cancelled. So this is the property of the factorial that I explained. From any factorial can be represented and can be stopped anywhere in the product, and the last term can be represented as the factorial, and that will help to reduce the fraction or reduce the factorial into a fraction. Okay, so this will be the property that is useful in such cases. So I will end up here, and next we will talk about some more properties of the factorial, and then after on this series several iterary, you can say, or the corollary that can be established, that is useful directly while we will solve some of the exercises, or we will solve exercises basically. So that formulas, the sub formulas we will establish, and I will make it through this generic representation of the binomial series. So thank you for now. Good night.